Solar energy powers over 1 million homes in Canada, and it has enormous potential, but it only has an efficiency rate of 10 to 20%. Why is this? Does the sun not have free, abundant, never-ending energy? That's what I'm going to be talking to you about in this video. We'll go over the root cause of the issues at hand with solar, and we'll also introduce quantum dots and how they could come together to create a solution. And first, what is the process of actually generating solar energy? If we look at solar panels, we see that they are made up of silicon photovoltaic cells, and these absorb sunlight in the daytime. In a cell, there is a semiconductor wafer made of one positively charged layer of silicon and the other negatively charged. And this creates an electric field, and so when the sun hits the panel, the current is generated, and the electrons escape their atoms in the wafer and flow through that electric field because they are attracted to the positively charged terminal. And so that creates electricity, specifically direct current electricity. If you don't remember, alternating current is what powers our appliances, so DC has to be transformed to AC with an inverter, whose entire role is to make these kinds of conversions. Then this AC electricity will go to the switchboard, which sends electricity to appliances, and then bidirectional meters are used to measure the electricity consumed. And it's really nice because it measures both ways, so if you use less than what's given to you, then that is taken into account when you're charged. Charged with money, not electricity. I just wanted to clarify that. Like I said before, although solar has great potential, it's super difficult to harvest in a maximal way. And that's why the efficiency is so low. It's also still super expensive, despite the cost going down over the years. But believe it or not, pretend I didn't tell you at the beginning of this video, there is a way to solve both of these major roadblocks with nanotechnology. Over 93% of today's solar cells use silicon as their superconductor material, and scientists identified this as a key problem with solar that was contributing both to cost and efficiency. Cue quantum dots. Quantum dots, sometimes called nanocrystals, are circular semiconductor particles a few nanometers in size. They can emit light of different colors when they come into contact with UV light by absorbing light from one wavelength and converting it to another. What's super cool about them is that despite their small sizes, they have some pretty incredible properties. One of them being their ability to create multiple exciton generation, otherwise called MEG. MEG occurs in quantum dots, where the energy of an absorbed photon, generally 2 or more times the band gap, can generate 1 or more excitons, instead of being disposed of as waste in the form of heat. Why is this important? The MEG effect actually is more substantial than it may sound, because it can create more electrons per proton from the sun's rays, even harvesting up to 7 electrons for 1 proton. And that's crazy because that's not a possibility with silicon solar cells, because all that extra energy is released as heat wastage. And efficiency could be boosted with quantum dots. Another pro is that quantum dots are made from inexpensive and abundant materials, and they can be manufactured at room temperature, and they can be applied to a ton of different kinds of materials, so they are super, super flexible. Now, obviously, there are some downsides to quantum dot solar cells, otherwise they would already be widespread. The main con is what they are made of. And although they're cheap and accessible, like I just told you, they're made from toxic materials like cadmium, selenium, and lead. And with the metabolism and degradation of quantum dots, they can accumulate in the kidney, spleen, and liver. Not so great. Another shortfall that's still being figured out is quantum dot surface defects. These can act as traps, and that hinders the ability for electrons and holes to come back together. This makes the quantum dots flicker or blink, and by putting a shell around the core, this can actually be minimized, but they have some issues with alterations of optical properties, so the sizes of the particles would change, and that's actually even more difficult to control. Obviously, charges getting trapped in this material isn't great, but advancements are being made, and with the other problem of materials, there are also rapid developments there. Solar energy could revolutionize the sustainability industry. We just need to figure out how to make it more efficient and cheap, and we may have found a way to do that with quantum dots. Now all we have to do is figure out all the little details, and one day solar might be powering your house with quantum dot cells. Thank you.